All right, hello everyone. Now we're going to be going over section 1.6, which is multiplying and dividing real numbers. So for this section, we have five objectives. Our first objective being we want to find the product of real numbers. Our second objective, we want to use a reciprocal of a number to apply the definition of division. Objective 3, we want to use the order of operations when multiplying and dividing real numbers. Objective 4, we want to translate words and phrases that indicate multiplication and division. And our last objective, objective 5, we want to translate simple sentences into equations. So we know that the result of multiplication is the product, and when we multiply positive numbers together, we get a positive product. This is what we've been doing in the past. We've only really been working with our positive numbers. So when we multiply positive numbers, we get a positive number. We also have the following property, which is that for any real number x, the following holds. So if we multiply any number by 0, it's going to be equal to 0. So we see we have x times 0 is 0, and 0 times x is 0. So any number we multiply by 0 is always going to be 0. The order doesn't matter. That's called the multiplication property of 0. For objective 1, we want to find the product of real numbers. So now these are going to include negative numbers. So when multiplying a positive and a negative number, we can also consider it repeating addition. So if we have something like 3 times negative 2, well, that's the same thing as saying negative 2 plus negative 2 plus negative 2, which is equal to negative 6. So what we find here is that multiplying a positive number and a negative number, we get a negative product. So if you have one of each sign, your answer is going to be negative. So for example, 2 times negative 4 is negative 8, negative 10 times 3 is negative 30, negative 15 times 4 is going to be negative 60. We also find that multiplying a negative number by a negative number is going to give us a positive product. So this tells us that negative 3 times negative 2 is 6, negative 6 times negative 4 is 24, negative 5 times negative 5 is going to be 25. So these facts give us this property, that the product of two numbers with the same sign is always positive, and the product of two numbers with different signs is going to be negative. So that's what you want to remember when multiplying numbers with signs together. If they have the same sign, it's positive, even if they're both negative. And then if we have a multiplication problem with different signs, we have a negative times a positive, that will always be negative. So moving on to objective 2. We want to use a reciprocal of a number to apply the definition of division. Recall that reciprocals are pairs of numbers whose product is 1. So reciprocals are also known as multiplicative inverses. So if we have a full number 3, its reciprocal is 1/3. 1/2 is 2, and 100 and 1 divided by 100. If we work with fractions, which we've done in the past, whenever we want to find the reciprocal, we're just going to switch the numerator and the denominator. So if we had the numbers 5/7, it would turn into 7/5. So we just switch our numerator and denominator whenever we're working with fractions. So now with our definition of division, we say that for any real numbers x and y, where y does not equal 0, which is important, which we'll go over a little bit later, x divided by y is the same thing as saying x times 1 divided by y. So to divide two numbers, we want to multiply the first number, the dividend, by the reciprocal or the multiplicative inverse of the second number, the divisor. So for example, 15 divided by 3 is the same as saying 15 times 1/3, which is going to be 5. So the following forms all represent division, where of course y is still not equal to 0. X divided by y with our division symbol, x over y in our fraction form, x over y again, just another different way of writing a fraction form, and then we have our y with our division bar over x. So dividing signed numbers. The quotient of two numbers with the same sign is positive, and the quotient of two numbers with different signs is negative. So it's the same thing that we have for multiplication. So whenever we're dealing with multiplication or division now, if we're dividing by numbers with the same sign or multiplying, it's always going to be positive. And if we're dividing and multiplying with numbers of different signs, it's always going to be negative. For example, 15 divided by 3 is 15. Negative 15 divided by negative 3 is, 15 divided by 3 is 5. Negative 15 divided by negative 3 is 5. 15 divided by negative 3 is negative 5. And negative 15 divided by 3 is negative 5. So we see that when we had numbers with different signs, it was negative, and with the same sign, it was both positive. So our first example, we just want to find the quotient here. So if we want to find our quotient, we have negative 1/8 divided by negative 3/4. So we have fractions here. We want to write this as multiplication with the reciprocal instead. So negative 1/8 is going to stay the same. But now we're changing our division from multiplication, and our negative 3/4 becomes negative 4/3. So we just switch our numerator and our denominator. And now since we're multiplying fractions, we can multiply these numbers together. So for simplicity's sake, each one of these fractions is negative. So we know that when we multiply these together, we know that it's going to be positive, since each one of our fractions is negative. So in our next step, we're going to drop our negatives. We know that our final answer is going to be positive, so we can drop our negatives now. So we can say multiplying two negative fractions product is positive. All right. So now we multiply our numerators and we multiply by our denominators. So our numerator is going to become 1 times 4 divided by 8 times 3. So now we have, essentially, we can simplify, and our numerator is going to become 4, and in our denominator we have 8. We know we can separate 8 into 2 times 4, so now we can use our property of 0. Because now we have a 4 in our numerator and a 4 in our denominator. So we can write this as 4 divided by 4 times 1 divided by whatever was left over, which was 2 times 3. Let's go to our next line here. 4 divided by 4 becomes 1 times 1 divided by 2 times 3. 2 times 3 is just 6. And since we have 1 times 1 over 6, we know our answer is just 1 over 6. So that would be our final answer there, and that was with our multiplication of our reciprocals. Oh my goodness. My cat just knocked over my camera. All right. Moving on. We always have to be careful dividing when 0 is involved. So division involving 0 for any real number x with x not equal to 0. 0 divided by x is 0, but x divided by 0 is undefined. So if 0 is in our numerator, our answer is just 0, but if 0 is in our denominator, it's undefined. So there is no answer. So for example, 0 divided by negative 10 is 0, but negative 10 divided by 0 is undefined. We can write our signs in different ways, but they do have equivalent meanings. So for some equivalent forms here, for any positive real numbers x and y, the following are equivalent. Negative x divided by y is the same thing as saying x divided by negative y, which is also the same thing as having a negative x divided by y. We also get that negative x divided by negative y is the same as positive x divided by positive y. So with our first term there, that negative x divided by y, we generally use the form for negative final answers, and with x divided by y, we generally use this form for positive final answers. So we do normally use these forms, but you can remember that whenever you have these forms, you can write them in any one of their other equivalent forms as well. So for objective 3, we want to use the order of operations of multiplying and dividing. So in our example 2, we want to perform the operations. My cat is just having a field day right now. So for example 2, we want to perform the operations. And for A, we have -5 times 3 plus -6 times -2. So when we multiply -5 by 3, since we have a +3 and a -5, our answer is going to become negative. So we're going to get a -15. Then we have plus -6 times -2. Since -6 and -2 have the same sign, they're both negative, we know that their answer is going to be positive. So we're going to get -15 plus 12. And now to solve, remember that we want to find our absolute value. So I'm going to write this out one more time, and now in the future I'm just going to verbally go through the process. So we take our absolute value of -15, which gives us 15. Our absolute value of 12 is 12. Since 15 is greater than 12, we subtract 12 from 15 to get 15 minus 12 is equal to 3, and carry the negative symbol from -15 to get -3. So -15 plus 12 is going to be -3. For part B, we have 3 times -4 minus 2 times 6, all divided by 5 times 2 minus 4. So our 2 minus 4 is a grouped symbol, or it's in our grouping symbol, so we want to solve for that first. So we're going to leave our numerator alone. We're going to have 3 times -4 minus 2 times 6. And now in our denominator here, we have 5 times 2 minus 4. And remember, 2 minus 4 is the same thing as saying 2 plus -4. So the absolute value of -4 is just +4. The absolute value of 2 is 2. Since we have 4 and 2, 4 is greater than 2, so we end up subtracting 2 from 4 to end up getting 4 minus 2, which is 2. And since the absolute value of 4 was larger, but our original number was -4, we carry that negative in order to get -2. So our denominator here is going to become 5 times -2. So now we can continue. So now we want to solve our numerator and our denominator separately. So 3 times -4, we have a positive number times a negative number. So we're going to end up getting -12. Then we have minus 2 times 6. And 2 times 6 is just 12. They're both positive, so we end up with a positive number. Then in our denominator, we have 5 times -2. Since 2 is negative and 5 is positive, our answer is going to be -10. So remember, whenever you have subtraction, you can always choose to add the additive inverse instead. So this becomes -12 plus -12 over -10. -12 plus -12 is going to become -24. And we're still dividing by -10. So since we said before with our equivalent forms here, if our numerator and our denominator are both negative, then our answer here is going to become positive, or our next values. So since we have a -24 divided by -10, it's the same thing as saying 24 divided by 10. And now we just want to do our final simplification. We see 24 and 10 are both divisible by 2. So we can separate 24 into 2 times 12. And we can separate 10 into 2 times 5. Then using our property of 1, this gives us 2 divided by 2 times 12 divided by 5. 2 divided by 2 is just 1. So this gives us 1 times 12 divided by 5, which just leaves us with our answer of 12 divided by 5. So, all right, moving on to objective 4. We want to translate words and phrases that indicate multiplication and division. So below we have the charts of words and phrases that indicate multiplication and division. So starting with multiplication, we have words like product of, times, twice, which just means 2 times, triple, which just means 3 times, of, which is used with fractions, so 1/2 of 10, something like that, that indicates multiplication. Percent of, so whenever we use percentages, that would also be multiplication. And as much as, so 2/3 as much as 30. So in this case, we would also have multiplication. So all of these words indicate our multiplication, and we can express them in our numerical expressions. So phrases that would indicate division would be things like quotient of, divided by, or ratio. So we have something like the ratio of 2 to 3, that just means 2 divided by 3. So when translating a phrase involving division into a fraction, we write the first number named as the numerator and the second as the denominator. So whenever we have the quotient of -24 and 3, our first number, which is -24, it's going to be our numerator, and our second number, which is 3, is our denominator. And so that's how we normally write out our fractions or divisions. We always write that first number first, will also be the numerator, and our second number will be our denominator. So, all right, let's do an example. Example 3 here, we want to write a numerical expression to the phrase, and then we want to simplify. So, our phrase is 5 times 6 divided by the sum of 8 and 3. So we have quite a few things going on here. So let's kind of mark up our phrase here. 5 times 6 indicates multiplication. So multiplication. And then we have divided by the sum of 8 and 3. So divided by is indicating division. We can also say that this is indicating that we can also use a fraction bar. So, and now we have the sum of 8 and 3. And if we're using this fraction bar, this also means that 5 times 6 is our numerator. So the sum of 8 and 3 is our denominator. But we also have the sum of 8 and 3. So the sum meaning addition. So we start with our multiplication in our numerator, we have our fraction bar, and then we have our denominator, which is going to be using addition. So let's put these all together. Our numerator is going to be 5 times 6. So multiplication 5 times 6. Or we're going to say this is equal to, or let's just write equal to 5 times 6 divided by, we're going to write that fraction bar, the sum of 8 and 3. We're using addition, so we could say 8 plus 3. And we can put some grouping symbols around if we would like. So now we have this expression, 5 times 6 divided by 8 plus 3. Well, let's simplify our numerator and our denominator. Our numerator is going to be 5 times 6, which is 30, divided by 8 plus 3, which is going to be 11. And 30 and 11 have no more simplification, so 30 divided by 11 is our final answer. Now, objective 5, we want to translate our simple sentences into equations. With example 4, we want to write each sentence as an equation using x as the variable. So in this case, we're just writing our equations. We're not solving for them or simplifying. So let's put some quotes around these. So for part A, we have triple a number plus 2 is 17. So I want to do the same thing. Let's mark up these sentences. Triple a number means, or triple just means 3 times. So 3 times something. That's something being a number, which is x. So we have 3 times x plus 2. So this is telling us addition. Plus 2 is, and remember that is tells us that it's equal to 17. So now all of our words here have been broken down into what we can use as our numerical expression. Our first 3 words there, triple a number, is expressed as 3 times x. Then we still have addition, so plus 2. Plus 2 is 17, or is equal to 17. Let's write that as a little arrow. And this is equal to 17. And this would be our expression. We can also just write it as 3x plus 2 is equal to 17. We don't have to have that multiplication symbol. But all right, let's do our last example here. So let's move this last word up so we have room. So we have the quotient of 21 and a number is -7. So we have the quotient. And the quotient is telling us that we are using division. We're using division, and we have 2 terms. So we can use our first term as our numerator and our second term as our denominator. Our first term being our quotient of 21. So 21 is our numerator. And a number. So that and is our fraction bar. A number is our denominator, which we know is x, since we're using x as a variable. And then we have is -7. And that is, remember, is same thing as saying equal to. And then that negative, we know, just means the symbol for negative. So writing this out here, we have the quotient of 21 and a number is -7. Our numerator being 21 and a number x. So we have 21 divided by x is equal to -7. And that would be our final answer there. So, all right, that would be the end of section 1.6. And next we'll be doing section 1.7 to finish off the week.